Alright, in this lecture I'm going to talk about some topics from 4.3, and the first one I'm going to talk about is called the mean value theorem. Alright, so we actually saw a version of the mean value theorem in 4.2 where Robert talked about Rolle's theorem. So if you called it Rolle's theorem, basically said that if you're on some interval from A to B and f of A equals f of B, then there is a point, well, really an x value, right? A point where x equals c, such that, that's what ST stands for, f prime of c is 0. All right, so visually this is not hard to imagine. So if I have some point, so let's say we're on the x-axis here, here is A, here is B, so they have the same value. Now recall the main condition is that f needs to be differentiable, right? But what we have is something like it goes up, and in order for me to come back down to B, this thing is going to have to turn around somewhere, right? So f of A equals f of B, this thing is differentiable. That means it's a smooth curve. There has to be some point, so that's the other thing about this point, x equals c. C is in the open interval from A to B. All right, so at this, we can call that C right there, right? So that's, at that point, the derivative is 0. The slope of the tangent line is 0. So basically, the mean value theorem is just kind of a generalization of this, in the sense that if we just kind of turn our picture this way, then we're going to get something. Notice that the line connecting f of A to f of B, that secant line has a slope of 0, right? This has a slope of 0 if we do what? F of B minus f of A over B minus A. We know that the slope of that secant line is 0 because f of B equals f of A. All right, so we have 0 over B minus A, whatever that is. So the mean value theorem says no matter how you turn this thing, you can find a point in between where the slope of the tangent line is equal to the slope of the secant line. All right, so another way to think of this, let me just draw a different picture here and then we'll talk about it a little bit. All right, so let's say I just, I have a point A and I have another point on the x-axis B. All right, and let's say A, here's f of A here, and I don't know, let's put f of B down here. All right, and we connect these with a smooth curve. So for example, I could come up here like this, come back down here, and then come back up and go through B. So something like this. This is just, kind of a random example. All right, but the point is we're connecting A and B with a smooth curve, meaning it's differentiable everywhere. Okay, so if I take a line, right, a secant line just goes through these 2 points. So I can just take a line, go through those 2 points. All right, so what's the slope? Well, the slope is, we already have it up here, right? It's just that in this case it's not going to be 0. It's just f of B minus f of A over B minus A. And what the mean value theorem says is that there is some point on the interior, in between A and B, there's some point C where the slope of the secant line is equal to the slope of the tangent line at that point C. So visually we can see that in a couple places here, right? So maybe somewhere around here, right? We could put in a tangent line that looks like it's parallel right? And then maybe, I don't know, somewhere like right here. So we can maybe call this C1, but there could be more than one. That's why I'm giving you this example. You know, we might call this, right, C2. All right? So again, visually, this idea makes sense. It's just saying that if you have this smooth curve connecting, you know, the point A and B, then somewhere in between, you will have a point where the slope of the tangent line, which is the derivative, is equal to the slope of the secant line connecting those 2 points. All right? And as I said, this point C might not be unique. You could have many points in between A and B, depending on, you can kind of think of a sine curve. If you picked A and B far apart, because you have this kind of up and down motion, there might be lots of points. Okay, so I just want to go through one example of the mean value theorem, kind of an algebraic example. So suppose we have the function y equals 1 over x, and we're looking at the interval from 1 to 4. So, you know, graphically, we know that 1 over x looks something like this, right? And maybe say this is 1 here, and I don't know, come on here, we'll call this 4. So I have these points right here. So there is a secant line that goes through those points, and we could find the slope of that secant line. So let's start with that first. Let's find the slope of the secant line, and then we want to find the point in between 1 and 4 where the slope of the tangent line is the same as the slope of the secant line. All right. So if we find the slope of the secant line, we can say that you know, f of 4 minus f of 1 over 4 minus 1. Well, that's just going to be 1/4 minus 1 over 1 over 4 minus 1. So that's going to be what? Negative 3/4 over 3. So dividing, you can just multiply by the reciprocal, right? Those cancel, and I end up with negative 1/4. I went through that quickly, but you should be able to verify that. That's just the slope of the secant line using this as our function. Okay, so that kind of looks right here, right? We know this is going to be a negative slope, and although we haven't drawn it to scale, it looks like it's going to be small, right? It's going to be it's almost going to be, you know, kind of closer to parallel closer to horizontal than to vertical. All right, so what we'd like to do is see if we can find the point C in between 1 and 4 where the slope of the tangent line equals that. All right, well, the first thing we're going to need is the derivative, right? So the derivative, and there's lots of ways to do this, but you guys have all seen it before, so I'm just going to say the derivative is negative 1 over x squared. You could use the power rule, you can use the quotient rule, there's lots of ways to do that, but let's just trust me on that. All right, now what we want to know is there a point where the slope, is there an x value in between 1 and 4 where this is equal to negative 1/4? Well, we can solve this equation, or we could just kind of look at it, right? In order for this to be true, we know that x squared would have to equal 4, right? That means x could be negative 2 or positive 2, all right? But for our purposes, we're looking for a value between 1 and 4, so that's the one we want, right? It would be true, we could find one on the other side, but according to the mean value theorem, we're looking for a particular C, so it would be, I don't know, that's 2, basically right here. So if I've drawn this well, these aren't going to be very far apart, then the slope of the tangent line will be parallel to the slope of the secant line through those 2 points. So that's an example. It's more kind of a seeing what the mean value theorem means and how you might be asked to use it. You might be given a function and an interval and asked to find the value of C for which the slope of the tangent line is equal to the slope of the secant line.